Hello, and welcome to Lesson 4 under Unit 1, Concept 1 of Algebra. So, as a reminder, you should be completing your guided notes as we go. Our objective today, scholars will identify expressions that are equivalent. Equivalent just means equal to each other or the same value. So, what are equivalent expressions? They really are just expressions that have the same value. As a reminder, when they are equivalent, we can make one expression can be made from the other using different mathematical properties. So what properties am I talking about? Mainly things like combining like terms, distributive property, and I mean distributive property both as distributing and as factoring out things that are common. So let's look at some different expressions. Are they equivalent? That's our question here. So we need to think about whether or not they're equivalent. One way to do that is to evaluate the expressions with specific numbers for our variables. So we can try evaluating them for x equals 3 and see if they all give you the same value. If they do, then maybe try what happens if x equals 0 or x equals negative 12, whatever. But you want to evaluate multiple numbers just in case somehow that for that one value it does give you the same. The other way to check to see if they're equivalent, let me just erase this real quick, is to actually see if you can make one from the other. So let's think about this top expression. How could I simplify this expression? Well, I could take this expression and I could use my distributive property to distribute the 6 to both of these, which would give me 18x minus 24 plus 18. And then I could combine these two like terms. I end up here. So these two are definitely equivalent. They are equivalent. What about this bottom one? Well, remember what I said about the distributive property works more than one way. Here at the top, I use the distributive property to distribute the 6 to what's inside. The distributive property also works to pull out common factors. So 18x and 6 have a common factor of 6. So if I pull out this 6 times 3x minus 6 times 1. Pull that out, I have 6 times 3x minus 1, which is how I know that that is equivalent. Could I make another equivalent one? Yeah, I could. Instead of factoring out the 6, I could factor out maybe a 3. That would give me 3 times 6x minus 2. Or I could choose to factor out a 2. I could have 2 times 9x minus 3. All of these, this equation, this statement, this expression, this expression, this expression, this expression, this expression, this expression, all of these are equivalent expressions. They can be made from each other. So let's look at another set of examples. Are these 3 equivalent? Well, once again, I'm back to, in this case, it's harder to tell. We can put in some values and see what happens. But let's look at, could we get from this to this? So let's look at what the difference is. Well, when I look here, I see the difference is that they seem to have factored out the 5. So they pulled out the 5 and the x, right? So if I do 5x squared divided by 5x, I get x minus 3. And then they just brought down the rest of the plus 8. So these two are equivalent. What about this bottom one? Can I get from this to this? Well, it looks like if I use my distributive property here, I use my distributive property, right? I would have 5x plus 8x minus 24, which I could simplify to 13x minus 24, which is not the same. So this one is not the same. The top two are equivalent. This one is not. So now you're going to take some time to complete a classwork that asks you to create equivalent expressions from given expressions. If you have any questions, please come see me.